Awesome, guys. So today we're gonna be taking a look at first. Let's see who I think Elastic DAO, right? Let's take a look at what Elastic DAO is at first. So let's see what they do, what is their thing, if they're still alive. This is something really important. Every time you're gonna do a report, see if the project is still alive. First thing that I can see is their Twitter. Not a lot of followers. Let's see when was the last tweet that they did. Code4Arena follows them. So just by looking at their Twitter, I can kind of see that this project is not hanging out anymore, unless this is some sort of scam, which I don't think so. Hey Marty, welcome boss. So we are looking at Elastic DAO. We're just confirming if they're still alive. Looks like it's not the case. Let's take a look at the contracts. If there's any recent commits 3 years ago. So from that we already know that the project's not around anymore. Now let's go back to the report. Okay. So let me do the magic here. Where they are, Elastic DAO. Let's open this guy. Bem, let's see. First, take a look who are the judges. So he were the wardens. Rajev was one of the wardens. Interesting. Then we have a summary here. So apparently the scoped lines of code were around 2,000 lines or something. So yeah, not a small code base. So let's take a look at the system overview. First important piece of information about the protocol. Elastic DAO is a governance protocol that attempts to balance the competing interests between the different participants in a decentralized ecosystem. Elastic DAO achieves this by reducing the overall influence that money and early adopters have in existing DAO governance models. Okay, so they attempt to balance the interest between parties in DAOs. Okay, sounds appealing. Yeah. At the time of writing, voting within Elastic DAO system relies on the snapshot platform with an anticipated implementation of independent layer 2 solution following their launch. With this in mind, a majority of the voting logic is executed through a multisig. This multisig also acts as an administrator within the context of the proxy, Elastic DAO controller, burner, and minter contract. So the multisig is the administrator of all these contracts. The system relies on a layer 2 solution, which I don't know if it was ever implemented. So they're explaining that the core.elasticDAO defines the logic for deploy, initializing, summoning, and joining DAO. Elastic DAO Factory provides a singular approach for deploying DAOs and is meant to be managed by the first DAO, Elastic DAO. Elastic Governance Token is a rebase token that conforms to the ERC20 spec, so probably their collateral token. And storage follow a version of the eternal storage pattern. Never knew this one, huh? Let's give it a read. And are found on SRC models. Let's just know what is this elastic whatever pattern. People love to create this stuff. So eternal storage pattern restructs. No, this is really. Let's take a look and let's learn about this. Okay, this is not hard. We are hard. This is fucking shit. So the first thing to tackle is the loss of data during redeployment. What comes to mind is to separate the logic from the storage. The question is, how are we doing that? So okay, so that's what the eternal storage proxy is trying to solve. So we can go from the left side of this graphics to the right side. So first, 0x123, my contract address A, get A, returns A. Cool. Then we have another implementation that say, hey, my contract gets A, returns whatever is deployed at storage. I think this is a contract. Probably this is a storage contract. So in the storage contract, get A, and the storage contract has the functions. Okay, I think we understood what this means. Pretty much you have a smart contract for your storage. No problem. Let's go back. So severity criteria. Okay, let's go for the issues. First, high severity. Infinite minting of tokens by exploiting eternal storage pattern. Whoa, we just read about this and now it's being attacked. Okay. So attackers can overwrite the metadata in modules DAO.sol eternal storage contract by using the serialized call to change the expected configurator address to the attacker address. Interesting. This allows the attacker to change the DAO and potentially mint infinite tokens themselves. We can consider this a high risk because it will disrupt the economics of the DAO and that will prevent the system from performing. Do I have a... I really want to see this, the proof of concept of this thing. Where's the files changed? Okay, so this is the deployment.js, so this is probably the problematic code. Hi Will Boy, how's it going? We're going over some reports and we just saw a very interesting high severity here, exploring a external storage pattern. And we're trying to see, well, to find the problematic code. So we could see that in the initialized function, before we had the configurator that would read, the address, and then we would load this ecosystem instance passing in the controller and the default. These guys that try to implement some sort of Web2 data thing. And here is this controller model thing. This is fucking terrible. And then they do an instance. They just replace this configurator and load straight up this build ecosystem function, which was before maybe public and is now private. I don't know if this is the problem, but let's keep on looking. So this is the build DAO function, the new one. I want to see the problematic code. So before we would have this UID here, considering both the universal ID and the configurator address. But after this change, we remove the configurator address. And we also remove from these modules. What a terrible... No, sorry, it's not terrible. I can be wrong, okay? I shouldn't be saying this, but it's really strange for Web3, to have this Web2-like data thing. So before we had a kcheck, encoding, hashing, first encoding and then hashing the configurator address, and now we have a DAO model address. I want to see that function that became... Okay. Serialized. Do we have a function here on the import? The serialized call to change the expected configurator address. I wonder if we're talking about this, because before we had this configurator address. Interesting. I would like to see a proof of concept of this thing. Okay, interesting. Let's keep on. Well, the second problem is we can also mint all tokens we want by exploiting the storage pattern on ecosystem.sol. So first the problem was on DAO.sol, but we also have a problem on ecosystem.sol. Just by that you can already see how useful things like Code4Arena are, right? Like Unify, Code4Arena, all these things, they are really, you know, helping us, you know. Otherwise, if we don't have such solutions, we would be completely screwed because that would be hack after hack. Um, so they're saying that a similar exploit is possible because the side of models ecosystem, attackers can change the expected address to their own while bypassing the authorization check for this function. This allows an attacker to change the DAO ecosystem data, gaining full access of the DAO ecosystem, and it's also possible to change the DAO model address field to the attacker control plus contract. This attack vector allows attackers to mint infinite tokens for themselves and potentially break all DAOs created from ecosystem. You know, I really would like to see the proof of concepts of these things, you know. Too bad that we can only search, like sniff the code for that. I guess it's the same files we just saw. No? No, it's not. So we have this build DAO function, build ecosystem. So they added this completely new part to the file. How do I see the lead before the changes? Okay. Ah, I think I get it, guys. So look at this. So if I'm myself sending the instance memory. Oh no, okay. I thought these were reading instance, but this is no. Yes, I'm sending that myself. So I can just send whatever, and this pass will check. This will pass. What a rookie one, huh? Okay, I think now we understood it. Let's go to the next one. And again, you can exploit and mint all the tokens you want. They really like doing it, don't they? An attacker can change the expected DAO address to its own address in token.sol contract. The attacker can change the token parameter so they receive much more ether for the shares when exiting a DAO. When exiting the DAO, attackers could also steal all funds, effectively breaking the DAO model. Let's look at it. Now we're talking about token.sol, not, and we can see that looks to be an implementation done on. Looks to be like they send the same commit to fix everything. Let's take a look at token.sol. What was the change? Can I see the full file? I think the problem here is the same. Probably those parameters they were sent by the function signature, so you can just send whatever. And apparently they changed this. Cool, that's cool. And we have another high, a lot of highs in this project. By the way, they were really saved by the bell. Configurator contract allows infinite minting of tokens again. And it looks like we're seeing the same problem again. I will even put this as a duplicate at this point. New users can be blocked from joining. This one's different. The join function requires the user to send the exact amount of ether for the required shares. Attackers can survey the mempool transaction and see a tiny amount of way to the DAO contract to change the required ETH value to a different value than the user submitted. This griefing attack would preventing new users from joining the DAO. Malicious actors might also use this attack to prevent new votes from derailing the outcome of a proposal. Actually, malicious actors might use this attack to prevent new voting from derailing the outcome of a proposal. A normal DAO usage might also block new users from joining. Token curve parameters change as a result of new join transactions. During times of high demand, many transactions will fail. Effectively, this results in a self-denial of service. Let's take a look here on what he's talking about and how that was fixed. Once again, they did everything in one fucking commit, man. Like, really, come on, guys. Like, really. I hope nobody bought this token. Look, everything's one. Ah, okay, maybe it's an audit fixed branch and they put everything there. What was the file? The file was the joy function. Joy function. So before we had this delta lambda thing, and we would require the delta lambda to be smaller or equals than the token max lambda purchase. And I guess this is calculated with the balance in the contract. So whenever I send something and just change a little bit the balance in the contract, this will never match, you know. I guess this could be the problem. I really wish I could see how the delta lambda was calculated. Probably that's here somewhere. No? Oh no, you actually send the delta lambda. So I guess you send how much you wanna join. So how much you. Where are they working with message.value? Can I see the whole file? Only summoners, I wanna see the join function. Yeah, not really conclusive. Okay, didn't got this one so well, but yeah, let's keep on. So we have a wrong event parameters in the transfer from function. The emit approve event should occur when the message sender is not equal to from. The event should emit an approval from to message sender with the allowance, instead of emitting an approval message sender to allowances like we're doing, like I think they're doing. So this would be like inconsistency on the chain, I guess. So if you try to do anything off chain, you're gonna be suffering. Let's take a look at the code, what changed. So before, they were sending message for .sender as the first parameter, but as actually the second. So yeah, small one. That got classified as a high. There shouldn't be a high, but that's okay, I guess. Minter can call functions reserved for the DAO address. This is interesting. Elastic governance token.sol. The only DAO modifier is meant to only allow a DAO address to call functions like setBurner and setMinter. However, as currently written, this modifier allows message.sender to either be a DAO address or the Minter address. Now I'll read that again. In elastic governance token.sol, the only DAO modifier is meant to only allow a DAO address to call functions like set burner and set meter. So that means that only DAO should make sure that only the DAO address should call these functions. Cool. However, as currently written, this modifier allows the message sender to be either DAO or the minter. Let's take a look at that. Should be a simple change. So before we had both the minter. I mean, I know this is probably not the case, but minter is someone that can create more assets. So they remove this from the require and leave only the DAO is allowed. This is a high one for me, not the other one. This is okay. Let's go to the medium severity ones. And let's see how many we have. Quite a few. And do we have gas stuff? Yes, we have also gas. Let's keep on. Let's keep on. So for the medium, let's start here. No check to prevent fee burning. The collect fee function sends fee to a fee address in storage. However, there is currently no check to validate whether or not fee address has been initialized. An attacker can call collect fees to send the fees to the zero address, making recovery impossible. This attack will be used against new DAOs to burn the main revenue besides the token market. Okay. No check to prevent fees burning. The collect fee function sends fee to a fee address in storage. However, there is currently no check to validate whether or not fee address being initialized, which means that I can be sending fees to address 0. I need to make sure that this thing happens. So how do I do that? Let's take a look in the code. Real boy, feel free to open your mic, bro. This is open for everybody, by the way. Everybody can speak, you guys can say, hey, nice, this and that, whatever. So before, we didn't have this require, which means that pretty much we're gonna be sending fees to address 0, okay? Okay, let's keep on. Anyone can update the number of token holders. Hey, real boy.
Yeah, sorry to bothering you. Is it me or the stream has a bad quality?
No, not you. I have the same problem.
But it's really bad, like you guys can read nothing.
Yeah, almost
Yeah,
nothing.
because my Airbnb is really works well for me, but the internet is not the best. Let me try to maybe decrease a little bit the quality. So give me 1 second. I'll share again the screen.
Sometimes is Discord a problem, not
Yeah, but I think this is not Discord.
not your connection.
Thank you.
Maybe it's okay.
A little bit better now.
Yes.
Yeah, perfect.
Awesome. I'll even make it even less, FPS because we're doing reading and we don't need a lot of FPS for reading. So let's go for anyone can update the number of token holders. Okay. So the idea is what? The update number of token holder functions in elastic governance token.sol does not verify the caller. Anyone could call this function and set the value to 0. While this not put funds at risk, an attacker could set the value of number of token holders to max wins, resulting in an overflow and reverting transactions the next time. Update number of token holders is called to increment this number. So the idea here is that the function is lacking access control. Everybody can call it. And let's see if that's really the case. Let's see what is the actual problem here. Let me open. So before there was no check to make sure that these functions was only being called by the DAO address. What we have now is yeah, we just added the require. So I guess we were writing the assumption for the finding. So the initialize function does not check for non-zero values. The initialize function does not check if the summoners are all non-zero addresses, and if all the initialized summoners happen to be zero, the contract will have to be redeployed. Yeah, okay, so just add a check in the contract to make sure you're not initializing things with zero again, because they did it. Guys, if the screen lacks quality, let me know that I will try to change resolution or something. Yeah, so this is pretty much, I think, I guess I could have an array of summoners. Let's take a look at the function of the file. What is the name of the function again? Initialize. So I could send an array of summoners, and some of them could be zero. And yeah, I guess this will make some of the summoners being invalid. Potential for lock out of administrative access. The set controller function in Elastic DAO updates the controller address in one setup. If the controller is set incorrectly, administrative access is prevented because set controller includes only controller modifier that contract will have been redeployed. So what they're talking here seems to me that to change, the owner, the admin of a contract is a really good pattern to maybe do it in 2 steps. So you do it like you have like 2 or 3 days to change, or to revoke that decision. That's really helpful. Malicious actors can avoid a penalty. A DAO member may be able to predict when they will be penalized if they monitor the mempool for events related to the penalized function on the contract. This member can then avoid penalization by transferring their balance to another address and sending it back to the original account after the next block. Since the penalty transaction will revert if the amount is greater than the balance, an attacker could potentially front-run the penalty by calling the exit function with a minimal amount of ETH. Let's just read that again. A DAO member may be able to predict that they will be penalized if they monitor the mempool for events related to penalize. So it's watching the mempool to see if the transaction will happen. This member can then avoid penalization by transferring their balance to another address and sending it back to the original account after the next block. Since the penalty transaction will revert if the amount is greater than the balance, an attacker could potentially front-run by calling the exit function with a minuscule amount of ETH. They could also exit the DAO completely. This loophole provides potential incentive. So the idea is that the guy could see if he's gonna be penalized and leave the DAO before that happening. That's, yeah, I guess smart. Let's take a look at the code. So we have a new event, and this one is an interesting one because it involves MEV, And usually the way to deal with that is create some sort of commitment review scheme. And I guess that's what they try to do with this fail to fully penalize, and then they're gonna deal with that off chain, maybe block the addresses or something. This is an interesting one. Double spend allowance. A malicious attacker could execute a double spend attack on an allowance by front running the execution of a thru. Yeah, this is a classical known ERC20 problem. That you can gain more allowance, whatever. Let's go to the next one. Passing zero address for controller will require redeployment of the contract. Yeah, add a check for zero. I'm gonna jump all the low severities and I'm gonna go for the gas operations. The function validates the value of message sender equals to the deployer. Since this check is already executed in the only deploy modifier, it should be considered redundant in order to reduce gas consumption. Let's see if we have. So pretty much we're saying only deployer and we're doing this again. Completely pointless, I'd say. Is this screen good, guys?
Yes.
Yes, yes.
Awesome. Let's go for unused arguments. So someone's calling some argument here and they're not. So we used to have this ecosystem memory thing. Sorry, not really thing. I think this is a structure of some sort. And wasn't really being used, so they removed it. Cool. Inefficient calculations. SafeMal is less efficient than a repeated squaring algorithm. Furthermore, the exponentiation in elastic math.revamp is very expensive and can be hard-coded as 118. Whoa, I like this one. Whoa, so before they were actually calculating the weight of one if. And they can just say, hey, 118, like just do this, Nice, very interesting. Look! Whoa, bro. Imagine how expensive that was. Will boy, what would you do if you see that in a smart contract?
Well,
Would you
I would
fire
try
this person?
all the possibilities.
Would you fire this person or not?
I don't really know.
This is to calculate one if, man. They're doing this thing.
I will certainly check the power function of OpenZeppelin, and then I will try to.
No, but you
compare.
don't understand. They don't need the poll function. They only added this here to calculate one ether like this. You see, even in the finding, the researcher says can be hard coded as 118. But okay, let's keep on. Unnecessary storage of summoners. In elasticDAO.sol stores the summons in storage. Despite only using summoners stored in the DAO contract external storage model to save gas, the summoner storage within elasticDAO can be removed. Wow, they use the storage word many times here. Really hard to read. Unnecessary use of prevent reentry modifiers. That was a best name than non-reentry. Let's take a look. Many users, modifiers are used on functions that call trusted contracts and do not make any attacker-controlled arguments. elasticDAO initialize, so we're pretty much calling these everywhere, and we shouldn't be doing that. because it's expensive. So every function is, holding this thing, but they just did it with no reentrant. Maybe the reentrancy guard is a little bit more efficient in the way that he deals with that than the reentrancy protection. Look, this is a classical Web 2 thing, man. Services, models, controllers. These guys, they came from a very strong Web 2, web background, by the way. Yeah, okay, we know what it is. Let's keep on. A necessary calculation of deploy DAO count. The elastic DAO factory tracks deploy DAO count in a separate variable. The deploy DAO in token function updates this variable. This is a necessary calculation and an invocation of safe math because the deploy DAO count can be returned with a view that returns the deploy DAO address.length. So what he's saying here is that we're calculating how many DAOs were deployed, okay, in a variable. And we have a function to update this value. But we don't need to do that because can be returned with a view that just return the length of the array of addresses. So let's take a look. This is actually a good one. Let's take a look at the code. Just a reminder that everything is being recorded, so no, don't say something complicated. So before, we needed to pass this number, and we will be setting and using safe math to add one number, And now, we just do this. Beautiful, beautiful. So if you ever need to count an array, dot length, okay. A necessary call of elastic math. The elastic governance token and elastic DAO contracts imports both safe math and elastic math.elastic math. But this guy already imports safe math. So we are importing two files unnecessarily. Let's take a look at the code because it's not so clear in my head, although simple. So before we had the safe math here and the elastic math, and both pretty much elastic math was also calling safe math, so redundant, not necessary. Unnecessary checks in setBurned and setMinter functions. These functions check for return values, which is unnecessary. Boolean will always return true if completed without reverting. So yeah, they say here that they like to check things. Cool. We're gonna accept that. Unnecessary use of bytes 32 setting name. The events max voting lambda change and controller change have this parameter, which serves no purpose because the only place these events are emitted are in the functions set max voting lambda and set controller. So we have a parameter inside both these events, but I don't understand. Let's see the code. Hey Jake, how's it going? So we used to send this setting. Good. So you used to send this setting name thing here. Yeah, I don't really understand this, but I ain't even gonna think a lot about it because this is, nice. It was a nice report, huh? What you guys learned today? I learned, let me take a good look again. Yeah, mainly don't use, Web 2 structures to do your things, and yeah, okay. Yeah, let's keep on. Let's go to the next one. So we just came out of Elastic DAO, and now we're gonna dive into Maple.finance. And so the idea is pretty much to read every report ever on Code4Arena. It would take 1 hour, so you guys can estimate how much time we're gonna be working on this. I wanna know a little bit about the project. So I wanna know about what is Maple Finance. They are very famous and they're still working. So this is nice for a change. Transformed through tech, Maple bring capital markets on chain. Sounds fancy. Wow, they have a fancy website too. I really like this thing here. On Maple, credit professionals manage flash flow and lending business where pooled capital is lent to a wide range of institutional borrowers to fund and grow their operations. A never expanding range of liquidity pools are open to lenders. Wow, they have a really good marketing someone. I'm pretty sure that this is just a. Let's take a look. CEO, co-founder, and CFO. All boomers. Yeah, okay, this is the team. A lot of white people, they need to be more diverse. Okay. Okay, guys, we kind of know what they do. They offer money to lenders, probably over some fees. Now let's keep on. First nice thing, no high risk findings shows that the team is not rookie. And now let's go for the medium findings. Okay, loan of tokens with more than 18 decimals can result in an incorrect collateral calculation. It is possible for a user to mislead a pool delegate to a seamlessly. How do I say that word, Jake? Seamlessly.
Where?
How do I say that word? Seamlessly.
Oh. It is possible for a user to mislead a pool delegate to a seemingly innocuous loan.
Seemingly innocuous loan.
Seemingly.
You also got English for in open sense, huh? By utilizing a token with more than 18 decimals as collateral and lucrative loan terms. The final calculation within collateral required for drawdown. What is a drawdown? Never heard that word before.
Hey, did you say we were not supposed to talk on this call?
No, you guys are supposed to talk as much as you want, actually.
Oh, okay. I actually looked at this project recently. The summary, I'm pretty sure it's like a hybrid, like crypto traditional finance thing, where you can get crypto loans. I think using crypto collateral, but it's an under collateralized loan. So there's like a off-chain KYC process. They have like traditional loan people at the company. So it's like a hybrid.
Nice.
You can get under collateralized loans, unlike most places in crypto, which are all over collateralized.
Okay. So a drawdown is a decline in a historical peak of something. So guys, we can talk about the Bitcoin price. The drawdown would be everything after this, the peak. So this is the drawdown. Okay, nice. Okay, so get ready for math. Okay. Within collateral required for drawdown of loan library assumes that the collateral token of a loan to be less than 18 decimals, which cannot be the case as there's no sanitization conducted on the creation of a loan via the factory. This causes an underflow to the power of 10, which will cause a division to yield 0 and thus cause the loan to calculate 0 as collateral required for the loan. We advise the same paradigm as to what should be applied with secure. So let's We are aware that we cannot onboard liquidity assets or collateral assets with more than 18 decimals of precision, and we'll make part of that, or that will be part of our onboarding criteria. Nick Johnson, the judge, said, "This is a 100% legitimate issue that could be exploited against the contract using social mitigations, making this part of the onboarding strategy. When there's a technical mitigation requiring that the token to have less than 18 decimal or using the recommended mitigation is insufficient and could easily lead to an exploit due to human error. Based on WhatsApp methodology, I think this is actually super important, this thing. But now let's stop to read it. I'm judging this as a likelihood of low and an impact of high. Low because we need to pass the human review, and high because the impact of the book will be quite critical, resulting in a medium severity. So this is really interesting. So they use a balance to calculate. It's not just like from their head. They go for the balance between the likelihood of it happening and the impact. Like what is the final impact, and then based on that they calculate the severity. This is actually alpha right in here. Hey Cowardly, how's it going, bro? Um, Potential huge arbitrage opportunities. Let's see. MPL price decrease. When a protocol suffers a default, man, I don't know what you guys, seriously, like, you guys in India have a problems with mics, you guys need to buy mics. Buy mics, dudes. Like, it can be a cheap mic. When a protocol suffers a default, the BPT stakers are the first lines of defense, and the protocol trades BPT pool tokens for a single-sided liquidity asset of the balancer through MTP pool. I didn't understand a thing about this, man. When the protocol suffers a default, the BTP stakers are the first in the line of defense, and the protocol trades BTP2 tokens for single-sided liquidity assets of the balancer to MTP pool. Note that the pool token to a single asset trade is the same as burning the LP to receive equal amounts of underlying tokens and then trading out the tokens to receive an asset. So this is something really important. So a single side liquidity asset is the same thing as someone giving you the liquidity token, you having to change it back for the assets you had before and change it back to USDT, USDC, or whatever, you know. So yeah, this is very interesting. Okay, in reverse of this, despite a single asset A to a shared pool is equivalent to depositing all pool assets proportionally and then selling more of the asset A to get back all the other tokens deposited, added by balancer. This means on each default MTP tokens are sold for the liquidity asset. No, sorry. This means that on each default MTP, tokens are sold for the liquidity asset. As the default is potentially a huge amount that happens at once, and this create a huge arbitrage opportunity. I won't pretend I understood. I won't understood the thing. Can someone?
Uh, I
Yeah,
think maybe when he says default, it may mean like defaulting on your loan, like you're not
yeah.
paying interest on it or something like that, and so they're gonna sell any collateral or something like that that you have potentially.
Yeah. So
Yeah, maybe you have to like stake Maple tokens or something. I think that's probably MPT if you want to use their platform. And so if you default on your loan, they're gonna sell all your staked Maple or something. I don't know. I'm just kind of guessing.
And one thing that I'm seeing that there was a lot of back and forth with this finding. You can see that the judge and the team were all here. I wish I could see code. Can I? No, I can't. Potential.
It doesn't. I thought it reference code on that discussion.
Yeah, me too, man. But let's see. It was this one. It was this one.
Yeah, that one. It's nuts. So it's just an open issue with no. I guess you'd have to go find it in the code then yourself.
Yeah.
Well,
Let's keep on. Let's keep on. Okay. Bypass or reduction on the locked up period of the pool FTTs. In the pool.sol, the lockup restriction of withdrawal can be bypassed or reduced if newly created providers cooperate with existing one. So the idea here is that the restriction of withdrawal can be bypassed if the liquidity providers cooperate with new ones. So there's a way to gain the withdrawal. So let's see how that happens. First step, a liquidity provider, Alice, deposits liquid assets into the pool and mints some FTTs. She then waits for the lockout period days and calls intent to withdraw to pass her withdrawal window. Now she's available to receive FTTs from others. What? Let's take a look again. Alice deposits liquid assets into the pool and mints some FTTs. Then she waits for her lockup period. After that, she calls, "Hey, I intend to withdraw and pass her window." So there's maybe an error, maybe some code dependency or here. I think we can call this a racing condition, where she can pretty much change the state based on another function. 2. A new liquidity provider, Bob, deposits liquidity assets into the pool and mints some FTTs. Currently, he's not allowed to withdraw his fund by the protocol design. So what he's gonna do, he's gonna send his tokens to Alice, and Alice, let's see if that's the case. Bob and Alice agree to cooperate with each other to reduce Bob times waiting for the withdrawal. Bob transfers his FTT to Alice via the transfer function. Alice calls intent to withdraw and waits for the cooldown period and not notice that Alice's deposit date is updated after the transfer. However, since it's calculating using weighted timestamp, the increased amount of lookup time should be less than the lookup period. However, since it's calculating using a weighted timestamp, the increased amount of lookup time should be less than lookup period. In situations where the deposit from Alice is much larger than that from Bob, Alice could only even need to wait for the withdrawal cooldown period before she could withdraw any funds. I don't understand the fucking thing. Alice then withdraws the amount of FTD that Bob transferred to her and transfer the funds to Bob. Okay, I guess they're cooperating and he sends the token to her and she's selling the token. Okay, I guess this is nice. Not going for the lows, because one day what I'm gonna do is I'm gonna do one day just for lows. We're gonna go for lows on every project because they are faster, you know. So I'm just gonna go for the gas optimizations. No gas optimizations. Let's go to the next report. Margin swap. Finally a swap, huh? A lot of high risk findings. And a lot of medium findings. This will be a fun one. Now, interestingly, one of the Warden series are C. Michael, which is a total boss. And it was judged by Zach, very famous. I think he's in the group. Not sure though. Okay. Now I'm gonna see if that project's still around. So let's take a good look at that. Well, they have a website. Let's see the price at this point. And I want to aim for their GitHub too to see their last commit. Years, but this is probably very old code.
Right. Who's margin swap? Why are we looking at this?
So what we're doing is we're going over every report from every contest on Code4Arena. So we're reading every file, every researcher found on every project so far, because I think that will maybe could or could not help us, but probably will.
What happened to Maple Finance? I just transferred off this video for just a second.
Yeah, it's over. It's over.
Oh, that was it?
Yeah, that was it. It was a really small report.
Oh, all right.
Yeah, and looking here at Margin Swap, they have a really nice looking website. Although super generic, really nice looking. And these 5 here is low resolution, but really beautiful website. So I think they're still around. They are running. They have a price. The market cap is still there. So let's take a look at this guy. So the first high risk finding of margin swap was a re-entrance bug that allows inflating balance. One can call margin writer cross swap exact tokens for tokens function first with a fake contract disguised as a token pair. So there's some flexibility here for me to send my own contract as a parameter to be used in the function. When the amounts are computed by the amounts equal Uniswap style library dot gets amount out, you pay the amount in minus the fees, pairs. So what you're trying to change, what was gonna be the path to change, and what are the tokens you're looking for. The attacker contract returns fakes reserves that yield 1 BTC for the tiny input. So that means that I can create a fake pool contract that acts just like a normal one. And when I say pool here, we can think liquidity pools from protocols like Uniswap and other ones. And my contract will say that the tiniest amount of tokens is equal 1 BTC. So that will result, in maybe I can hop transfers and really get 1 BTC just by putting my contract in the middle. But they're talking about reentrancy. So let's see what is the case. The resulting amount is credited through registered trade. Afterwards, swap exact T for T, so token for token. You can call with almost no Ethereum, 1 BTC, 0, pass your attacker contract, and then you pass in. So in my head, they have a pool, they have a contract that acts as the oracle price, or they are setting the oracle price here. No, actually, they are setting the size of the swap here. They have the oracle price here, and this is the path. So from Ethereum to Bitcoin. So they call this with a fake pair and token amounts. At some point, swap is called starting the balance that is stored in starting balance, and then the attacker contract could call allows a reentrancy. How that reentrancy works? From the attacker contract, we re-enter the margin cross swap exact tokens for tokens. Now with 30 Ethereum, the 0, I guess, for the slippage. Yes, maybe. Then you go for the pair for Ethereum to Bitcoin. This function with the actual Ethereum Bitcoin pair contract, all checks pass. The funds receive an actual amount, and the alter swap continues execution after the reentrancy. The ending balance is bigger or equals the starting balance plus the amount dot length minus 1. Woo!
I
Fuck.
need to see some code on this one.
Fuck. I want some code.
But I mean, something's happening where this cross swap exact tokens for tokens is
There's no POC,
calling
man.
back into
There's no POC.
the attacker contract,
Yeah, so apparently you can
I guess.
inject
Unless
your,
this is some different
yeah,
kind of reentrancy.
you can inject your contract and then do a re-entrance from your contract. You know, I mean, there's no POC. It's really hard for me to make these, understand these things. Let's look at this. Missing a check from token to token, so I can pretty much do a swap from Ethereum to Ethereum. Attackers calls the cross swap function with a fake pair and the same token. But now he's saying that he's gonna swap 1,000 Ethereum for 0. When the amounts are computed, amounts gets amount out. The attacker called the fake reserves. The output, the return is 0. The attacker contract returns fake reserves that yield 0 output. When the function swap token for token is called, the functions are sent to the fake contract, and doing nothing passes all checks in swap. The call that follows, so man. The funds are sent to the fake contract, and doing nothing passes all checks in the swap call. That follows because in starting balances start after the initial fund. The full impact is not yet known, but registered trade could still fail when subtracting its amount and adding 0. At least this attack is similar to withdrawal, which is supposed to only occur after the cooling off period has passed. But this time lock is circumvented with this attack. Recommended moving the fund withdrawal to the first pair after starting balancing assignment. And add this check. Price feed can be manipulated. Anyone can trigger an update to the price feed by calling price feed get current price impact, sending the token in amount, and that force could block. So force the current block equals true. If the update window has passed, the price will be computed by simulating a Uniswap-like trade with the amounts. The simulation uses the reserves of Uniswap pairs, which can be changed drastically using flash loans to yield almost arbitrary outputs, thus pricing. Wrong prices break the core functionality of the contract, such as borrowing on margin, liquidations, and etc. Recommended against using the Uniswap spot price as the real price. Uniswap itself warns against this, and implemented swap price oracle using the price times cumulative last variables. Let's take a look and learn a little bit about this swap oracle thing, because this is something that people talk a lot. Let's just go really fast here on Google. Actually, let's buy Google, right? I'm being such a peasant. Let's go for ChatGPT.
About PWAP, or I think time weighted average price.
Yes. How to calculate a Uniswap's TWAR price oracle.
Probably, I don't know if I'd say Oracle, but
Example. Let's see if he's gonna understand it.
okay.
Okay, to start, TWAP stands for Time Weighted Average Price. It is a type of price oracle that calculates an average price over a specific time period, which can be useful for determining a fair value of the asset. Here's an example of how to calculate this price. Let's say we want to calculate the swap price of Ethereum to USDT on Uniswap over the past 24 hours. We need to gather the following information. The price of Ethereum to USDT at each time interval over the last 24 hours, so we can think on every hour. So I have 24 time spots. And the volume of trades, this is also nice, huh? So the volume of trades from Ethereum to USDT on Uniswap at each time interval over the past 24 hours. So I'll be looking at the average between how much was being traded and what was the price at that point. So to calculate, we divide the past 24 hours into equal time intervals. For example, we can divide it into 1 hour intervals, so we have 24 time intervals. For each time interval, calculate the volume weighted average price of USDT on Uniswap. This is done by multiplying the price of each trade during the interval by its volume, summing these values, then dividing by the total value trading during the interval. This gives us the VWAP for the interval. Calculate the average is done by multiplying each VWAP by a fraction of the 24. I mean, it looks complicated, but it's not. Show me a simple example.
I just need the equation.
Yeah.
No. Oh, wow.
So it's not that complicated, right? I mean, it's something that you can probably fiddle down with JavaScript and kill it in maybe 1 hour or something like that. So let's go back. So the recommendation is never look at the reserves at Uniswap. Always calculate using the TWAP Oracle price, which is a common contract on Uniswap. Okay. Then we have another high talking about inconsistent usage of apply interest. It's unclear if the function apply interest is supposed to return a new balance with the interest applied or only the accrued interest. What does accrued means? You know?
It means like say you're getting like staking rewards for the past 6 months, and so you get like 100 per month. Then I could say you have accrued 600 in staking rewards over the past 6 months.
Nice.
6 months.
Cool, very nice.
How much have you received, and then that you hold still?
Nice, okay, nice. So there are various usages of it. Some calls add the return to the value. Some calls add the return value to the old amount. So they are doing return bond amount plus apply interest, and some not. What the fuck is that? Ah, this is a text. Okay, so this is one situation. Oh, at the beginning the reports were really, balance with interest, apply interest. So here's maybe a different form of calculation. This make the code misbehave and return wrong values for the balance and the accrued interest. Recommend making it consistent in all cases, calling this function. So call the same thing everywhere, don't be calling different things in your code. Wrong liquidation logic. The below money tense threshold function decides if a trader can be liquidated. You know something that I never quite understood is liquidation bots. I really need to dive into this thing. Below maintenance threshold, cross margin account, storage account, internal boss returns a boolean. So first we load the loan, then we get the holdings, and then we calculate 100 times the holdings, gotta be bigger than the threshold.
Yeah, I think this is saying that you should always have 110% collateralization.
Okay.
Because of this 1.1, the following should hold. Like the value of what they have. If they have like 100, if your loan is for $100,000, and the collateral they have is $110,000, 110 divided by 100 I think that's 1.1.
Yeah,
So if it goes below that, holdings goes lower than that. Like it's like 105,000 or $100,000 divided by $100,000 would just be one, meaning you have 100% like perfect collateralization. But it's about to drop below that potentially, so that's why these usually and crypto price swings can move really fast. So they liquidate ahead of time, so you actually lose money.
yeah,
You
yeah,
take a hefty fee, so there's like a 10% buffer.
yeah. Interesting.
I think that's what's happening.
Yeah, so he's explaining that they intended the inverse, so it should be instead of bigger or equal, should be smaller or equal. And users that shouldn't be liquidated can be liquidated, and users that should be liquidated cannot be get liquidated. So yeah, users are credited more tokens when paying back debit with register trade and borrow. The registered trade and borrow is called with the results of a trade in and out amount. You first try to pay back any debt with the out amount, however, the full out amount is credited to the user again as a deposit in the adjust amounts. So you get twice whatever you were getting before. As the user pay back their debt and is credited the same amount again, they are essentially credited twice the out amount, making the profit on one out amount, making a profit on one out amount. This can be withdrawn and the process can be repeated until the funds are empty. Wow. Accounts account.holds token is never set. The add holding function does not update the account holds token map. You see how you have to audit something like this, you really need to have like some experience, with these protocols, and really dive into it, like into the code, because you're also expected to say these things, like the developer, he wrote the code wrong, he forgot to update a variable. You're also expected to come into these moments,
Yeah, this one seems like a pretty basic miss.
You also expected, this can lead to a critical vulnerability. So this is also important. So sometimes the developer forgot to add, to update a value. And there's two ways of reporting that. You can report that saying, hey, he forgot to update this value, or you can try to think if there's any way to change that mistake into a high critical vulnerability, So that's kind of what he's doing here. This leads to a critical vulnerability where deposits of the same token keep being pushed into account holding tokens array, but the sum is correctly updated in account holdings token. However, because of the duplicate token in holding tokens, array the same tokens is counted several times, getting holding amount function. Wow, this is so fucking hard, really. I think I'm gonna get a screen reader and we just comment, the text. That could be the best thing to do. So here we have the function get holding amount, passing in the address of the trader, visibility, mutability, overrides, and returns these beautiful arrays here. And the problem here is that holding tokens they have duplicate tokens with the same token, and you are getting like results on over every position. You're getting yield on every position of that array, even though it's the same token. So yeah, because this is just an ID, it's not the token, the address of the token, nothing. The margin halter cross closed account functions uses these wrong amounts to withdraw all tokens. So he's pretty much looping through the array, and if I have 100 positions, same user, same token, I'm getting everything. And the name of this find is, could be better named, to be honest. An attacker can just deposit the same token several times and have the token multiplied by several times, inflating the balance and withdrawing everything. Recommended correctly setting the accounts holding in the map at holding. Rewards cannot be withdrawn. The rewards for a recipient in incentive distribution.sol are stored in the storage mapping indexed by recipient, accrue reward recipient. And the recipient actual is the actual margin trading account. See updated accrued reward. These rewards are supposed to be withdrawn to the withdraw reward function, but message sender is never used here. Instead, of, but message sender is used here instead of the recipient parameter. However, message sender is enforced to be the incentive reported and therefore cannot be the margin trader. Nobody can withdraw rewards. Recommended removing the incentive reported check from the withdrawal function. So let me read through that again. The rewards for a recipient in this contract are stored in the contract mapping indexed by recipient. And the recipient is the actual margin trader. These rewards are supposed to be withdrawn with the withdrawal reward function, but message.sender is used here instead of a recipient withdrawer parameter. However, message sender is enforced to be the incentive reporter and therefore cannot be the margin trader. Thus, nobody can withdraw rewards. Recommend remove this modifier from the withdraw reward function. There's no code here. Let's see if there's a little bit of code. No code here. Okay. Last day is not initialized. The variable last updated day in incentive distribution.sol is not properly initialized. This means that the function update days total will end in a very large loop, which will lead to an out of guise error. Even if the loop would end, the variable currently distribution would be updated very often. Thus, update day totals cannot be performed. The entire incentive distribution does not work. If the loop would stop, the variable currently daily distribution is not accurate, resulting in a far lower incentive distribution than expected. So the idea here is that we never initialize last updated day. This will cause the function update date totals to end with a very large loop, because it's gonna be, pretty much maybe trying to come up for the last day. This will lead to an out of gas error, and even if it stops processing, the distribution will not be calculated properly. So let's try to see what's happening in the function. So here's the function. When the function is called, the now day is calculated like that, and the difference is pretty much now plus the end of the universe, because there's no value here, and we'll give it a lot of days, pretty much, to do everything. So yeah.
So it'll just always be 0?
Yeah, I think if you do like, so the day difference is today, which is the time in second, minus 0. So you're gonna have like the timestamp from 2007, from 1970, I think, 69 or something, and so it's a lot of seconds. You're gonna end up with a fucking huge 4 here, and you're gonna run out of gas. So what they should do is, at some point, probably when they deploy the contract, they should set this variable as block timestamp, So you have a smaller window of seconds to look through.
If last updated day is always 0, then whatever now day is, it doesn't matter. It'll just be minus 0, so it's always going to be the same. Now day is always going to be the same as...
Yeah, and nowadays, like something like this,
Or day diff is always going to be the same as now day.
Awesome. Let's go to the last high one. Impossible to call withdrawal reward. Fails due to run out of gas. Is that related to this thing? Now we have pieces of code. That's finally. So, based on testing, the days diff would be this number. And with the gas limit of this number, it stopped at iteration 270 due to the fact that the last updated day is not set, so it's zero. So it's linking this problem with a new finding. This is also something you guys need to be smart. How many findings can I take out of a problem?
Mm.
You know. Yeah, let's take a look at the code. We kind of understood what was happening before. So I send these trenches here, and let's see here. So we were doing this thing without never updating the last updated day. So pretty much this will be running like crazy. And another interesting thing.
Oh, wait. I think I kind of understand what you're saying now. Yeah, so nowadays is like a crazy high millisecond number
Yeah,
since
it's
the
timestamped.
epoch.
So it's timestamped
So
here.
the loop's gonna loop through as if the last time they updated it was like 1990, whatever the
Yes,
heck its
exactly,
epic date.
exactly.
Okay.
1969.
Oh gosh, that's a
So
lot of. It's gonna run the whole block out of gas.
yeah, yeah. Let me take a look at what we have for mediums. Not a lot of mediums. Let's go over them. So first is no default on liquidation threshold percent. So the contract does not define a default liquidation threshold percent, which means that it's set to 0. The below maintenance threshold functions uses this value, and anyone could be liquidated due the calculation here, always returning true. Once again, he's creating a find and linking it with another thing, so he's taking a medium out of a high. Sometimes we start with a medium and we end up with a high. So anyone can be liquidated immediately if the fault below maintenance threshold function is fixed. Then nobody could be liquidated, which is bad as well. I recommend using the full liquidation threshold like cross margin trading contracts. Missing check if paired tokens are equal, we saw that. No entry checks, we saw the re-entrancy also up there. So he's taking pretty much a bunch of mediums from the maintainer can be pushed out. The function liquidate in both contracts can be called by everyone. If a contract calls this repeatedly, the maintainer will be pushed out and eventually be reported as maintainer is failing, as the attacker can take the payouts. When a non-authorized address repeatedly calls liquidate, the following happens. Is authorized set to false, which means that this mapping of the current maintainer increases, so the maintenance failures counter increases. After sufficient calls, then the threshold that the maintainer is failing will be set to true, and this can result in the can take now being true, which finally will be executed. An attacker can push out the maintainer and take over the liquidity. I believe this issue is not a vulnerability due to the check online. If anyone ever comes and claiming the maintainers failure, they can do their job in the same way, in the next block to get all most failure. Okay. Oh man.
Wait, so they're saying it's not a vulnerability, but what's the judge saying? Maintaining the reported risk
Yeah, I
level.
think the idea here is to like everybody in the community can come and say, hey, this guy is failing. And he's thinking, okay, so an attacker could use that, but then he's also saying that someone can just come, so the maintainer can just come and start working again, that the attacker will lose all his hedge. So
Hey, I guess if they're saying it's a medium, then he still gets paid for it.
yeah, no. At that point here, we're talking about 2021. This was paying a lot of money. People were making 30K, 40K a month, with these findings. Um, it's not the same anymore, but still pays very well. Several functions have no entry check. We saw that the entrance. User can drain funds from margin swap by making under collateralized borrows if the price of the token has moved more than 10% since the last margin swap involving accounts. Since the last margin swap borrow liquidation involve accounts holding that token. I think this is related to the thing that you're saying before. But as for the size of the text, yeah, I guess this is it. Let's go for the diff max mean runtime gets the full value of 0. This variable is never set nor updated, so it gets the full value of 0. Okay. Okay.
Wait, when did this audit come out?
This one is from 1st of April of 2001. Price aware uses price from get amount. Oh, I think this is regarding the TWAP Oracle price again. Isolated margin declares but do not set the value liquidation threshold percentage. Once again, I think we're talking about the 110% liquidation threshold. There's no time lock for key variables. Usually they're talking about, ownership changes. You should always have a time lock, so the owner will change after 2-3 days. It was an interesting report, I gotta say. Got my head a little bit with liquidation stuff. Go on, Buggy. Yes, let me stop recording OBS.